Alright, so in this video what we'll be looking at is standard form. So when we are representing a number in standard form, the number should be or the number should resemble a times 10 to the nth power, where a should be greater than or equal to 1 but less than 10. So this is a inequality. I'll explain that. And n, as in the power n, is an integer. Now, what does these things mean? The inequality, the integer, what does it mean? So the inequality, let's explain inequality first. So they said that a should be greater than or equal to 1, but it should be less than 10. What does this mean? Now, this inequality, it's representing a set of numbers. So we're going to, I'm going to explain these set of numbers, and hopefully you're going to understand them. So it's a two-sided inequality, so I'm going to explain each side, depending on, I'm going to explain each side. So with the left-hand side, it says that a is greater than or equal to 1. And if probably some students are going to get confused, because usually teacher would teach them that to read it from that side and show elbow and all those stuff. But with the inequality, you can read it from either side or either side. So if we're reading it with respect to the 1, we would say that 1 is less than or equal to a. But if we're reading with respect to a, we would say a is greater than or equal to 1. Yeah, so we have to read it with respect to a, because a would basically be the subject. Or a, we want a to be the subject, or a should be the subject in this case. Now, this could have also been written as a is greater than or equal to 1. So these two, they're the same. It's just that basically the top one, a is on the right hand side, with the bottom one here, a is on the left side. But this one, we want to get familiar with this one. So let's see if we can list some values that is related to this inequality. A should be greater than or equal to 1. So what values would satisfy this inequality, or what values would make this inequality true? Now, for a, they said a should be greater than or equal to 1. Now, let's say 1. Would 1 satisfy this inequality? Probably some students would say yes, probably some would say no. Now, let's see. 1 greater than equal to 1. Now, if you realize I replaced a with 1. Now, is 1 greater than 1 or is 1 less than 1? No. But if you realize this small line here means equal. So 1 is equal to 1. So that means it would satisfy this inequality. So I'm going to open my curly bracket here. So we know that all values greater than 1 would satisfy this inequality. So it would go straight up to positive infinity, all values. But let's focus in on the other side of the inequality. They said that a should be less than what? Should be less than 10. Now, what would be the first value that would be less than 10? And I'm referring to whole number values now. 9, 8, 7, 6, right back down to all the 0, because I said whole number values. All these values, so right down to 0, would satisfy this inequality. Now, as I said before at the beginning of the video, I said that this inequality, a should be greater than or equal to 1, but less than 10. It's representing a set of values. Let's see if we can identify these values. Now, I'm going to rewrite inequality. So let's rewrite it using a different color. So what are the values that would satisfy a greater than or equal to 1, but less than 10? Let's see. Let's see what are the values that would satisfy this inequality. Now, the first value that would satisfy this inequality would be 1. Because 1, it's not greater than 1, but it's equal to 1, and it's also less than 10. Now, 2, 3, 4, 5, 6, 7, 8, 9, would 10 satisfy this inequality? Let's see. It says that a should be greater than or equal to 1. So 1 is 1 greater than 1. No, but it's equal to it. So 1 would satisfy that inequality. This inequality. 2, yes, it would, because it's greater than 1. 3, greater than 1. 4, greater than 1. 5, greater than 1. Right up to 9 is also greater than 1. Now, 10 is also greater than 1, but is 10 less than 10? No, it's not. 10 is equal to 10, so that means we would not include 10 in the set of values. So 9 would be the final value. So these values would satisfy this inequality. Now, if we're going to include, so these are the whole number values that satisfy this inequality. No negative values would satisfy this inequality. Now, what about decimal numbers? Yes, 9.1, 9.2, 9.3, even 9.9 would be less than 10. Even 9.9 would be less than 10, and it's also greater than 1. If we use 1.5, yes, 1.5 will satisfy this. So this inequality, it's representing a specific set of values. These are the values. And as I said before, we could also include some decimal values like 1.3, 1.09, 3.5, 9.999. All of these decimal values would satisfy this inequality. So let's go into the other section of this inequality, this standard form thing. So what I explained before, I explained the inequality, because I said a should be greater than or equal to 1 but less than 10. Let's look at the n part. Now, writing back basically, let's say this is the formula, or this is our formula. Now I have explained a. Let's talk about n. I said that n is an integer. Now, what are integers? What are integers? Now, integers are positive and negative numbers including 0. So if we're going to list some values or some examples for integer, we could start by, so all values are basically integers, every single one, including 0. So how I explained it, I would define it as integers are positive and negative numbers including 0. Why did I say including 0? Because 0 is neither negative or positive, but 0 is the first whole number. So these would represent n, integers. Now, what I'm going to do, I'm just going to run through a few examples with standard form. So say, for example, we have a number, for example, 9, and we want this number to be written in standard form. Let's see how we would write this number in standard form. Remember, when we're writing a number in standard form, it should resemble this form. It should resemble it. So let's see, we have a 9. Now, let's look at the inequality. A should be greater than or equal to 1, but less than 10. Does this number 9 satisfy the inequality that we have here? So if we should put 9 in the middle, I'm just doing this for explanation's sake, because in the exam I don't expect students to be writing numbers inside an inequality and then try to justify. You should understand the thing before you go in the exam, or understand the topic before you go in the exam. So 9 is 9 greater than or equal to 1. It's not equal to it, but it's greater than it. So that means it satisfies the left hand side. Is 9 less than 10? Yes, it also satisfies the right hand side. So what we need to do, remember, we should have this attached to n, this section. So I'm going to have to a, because 9 is representing a now. I said n before. So we should attach this section to 9. So our answer should be 9 times 10. Now, what is the n going to be? Now, as I said before, this 9, it satisfies the inequality. So what value could I put at n that would make sense? We could not use 1. If we use 1, this would be saying 10 times 1. Now, 10 times 9. Now, 10 times 9 is 90. 90 is not the question. 90 is not the question. Now, let's try another number. If we should put 9, so this is not the answer, this. So if we should put 9 times 10 to the 2. Now 10 to the 2 is 100, as in 10 squared is 100. So if we put 9 times 100, that's 900. No, 900 is not the question. Let's try another one. 9 times 10 to the 0 power. Now, does this make any sense? Remember, the question is 9. And whenever we're putting a number in standard form, when we solve back that standard form representation of the number that we had before, we should get back the original number. Now let's see. 10 to the power of 0, that's equal to 1. So 9 times 1 is 9. So yes, get back the 9. So that means 9 represented in standard form is 9 times 10 to the 0 power. So I'm just going to run through. Probably this example was a bit too technical to start out with. So let's run through some simpler ones. So let's say I had 0.0035. Now that's the number we're going to represent in standard form. Now remember, a should be greater than or equal to 1 but less than 10. So let's look at this number, 0.0035. It's not greater than 1 and it's not equal to 1. So that means we're going to have to do something with this number. We're going to have to manipulate this number. And as I'm working each question, each example, I'm going to solve it back to get its original number to see if I can get it to understand these things better. So as I write the number in standard form, I'm going to prove back the or solve back the standard form question to get back the original number, or the standard form representation to get back the original number. So that means I'm going to have to manipulate this question so that it fits or so that it matches this inequality. So to manipulate this number, I'm going to have to move the decimal point. So let's see. If I move it one place to the right, I'm going to have 0.035. It does not satisfy A, because remember, A should be greater than or equal to 1 but less than 10. This number does not. Let's move the decimal point again. I'm going to get 0.35. Now, does this number satisfy the inequality? No, it does not. It's not equal to 1, nor is it greater than 1. Let's move the decimal point again. I'm going to get 3.5. Now, 3.5, does it satisfy the inequality? 3.5, yes, it's greater than 1 and it's also less than 10. So what I'm going to do, I'm going to have 3.5 times 10. Now, in this particular example, I had to move the decimal point to the right. Now, when you move the decimal point to the right, you're going to realize that there's something is going to happen to the power, the integer n. Remember, the standard form should resemble a times 10 to the nth power. So let's see what happens when you move the decimal point to the right. Now, how many times did I have to move the decimal point? I had to move it 1, 2, 3 times. So the power is going to be 3. Now, let's solve this to see if we're going to get back our original question. And please, I hope that you students aren't lost. So let's prove back this. Now, 10 cube, we know that 10 to the third power is 10 multiplied by 10 multiplied by 10, which is equal to 1000. So if I should multiply 3.5 by 1000, what's going to happen? Now, 3.5 times 1000, it's going to give me 3, 5. I'm going to cross off one of these zeros, 1, 2. So I'm going to get 3,500. Now, was 3,500 the original number? No, it was not. So that means something has to be wrong with this. What can we do to this? Let's see. Remember before I said that n. What is n? N is an integer. So the positive 3 is not going to work. Let's try something else. Let's use a negative 3 in this case. So I'm going to have 3.5 times 10 to the negative 3. Now, whenever we have a negative power, what we can do is a law of indices, and I know that I haven't went through laws of indices with my students, but hopefully seeing it now, you'll understand it later on. So we already know that 10 cube is 1000. So 10 to the negative 3, what is that equal to? We know that 10 cube is 1000. But if you realize I only used up the 3. Now the negative 1 means I'm going to have to flip or reciprocate this 1000. So that means I'm going to have 1 over 1000. So 10 to the negative third power is equal to 1 over 1000. So 3.5 multiplied by 1 over 1000. So basically what I'm doing, so this is 3.5 over 1 multiply, so I'm going to have 3.5 over 1000. Now 3.5 divided by 1000, you're going to realize that the answer is 0.0035, and this was the question that we started out with. So when we move the decimal point to the right, that means the power is going to be negative. If we move it to the left, it's going to be positive. I'm going to work an example like that. So I'm going to put an example right here. So let's say we had 15.6. Does 15.6 satisfy the inequality up here? No, it's greater than 10. Also greater than 1. It's greater than the 10, so that means it cannot work. What can we do? We're going to have to manipulate this question again. So I'm going to have to move the decimal point. So if I should move the decimal point to the left in this case, I'm going to have 1.56. Now, does this satisfy the inequality? Yes, it does. It is greater than 1. Not equal to it though, but it's greater than 1, and it's also less than 10. So I'm going to have 1.56. Remember, putting a number in standard form, we should always have the times 10. So it's going to be times 10 to the, how many times did I move the decimal point? To the first power. So let's work this out and see if we get by the original question. So remember, this is the original question. So 1.56 times 10 to the first power. Now 10 to the first power, that's just 10 times 1.56. Now 10 times 1.56, that's going to give me 15.6. If you realize, end up back with the original question. So indeed, the answer is 1.56 times 10 to the first power. So what I'll be doing in the next video is to work some past power questions pertaining to these things, and hopefully you'll understand with each example as we're going along.